Problem 21, where we are given that the numbers of each row and numbers of each column of a 5 by 5 array of integers form an arithmetic progression of length 5. The numbers in positions are given, and we have to find a number in position 1, 2. And if we see, we basically have to find this number that is given in position 1, 2. And we are given a very important piece of information that this is an arithmetic progression. And as we know, in the arithmetic progressions or the sequences, the difference is constant, right? So to solve this problem, we can start from this lower right corner. And as we know, we are having a 0 here, right? So I can then call the next term, let's say x. Then I can say this is 2x, 3x, and 4x. The reason is the difference, it is constant, right? So therefore I can write terms like this. And similarly, if I go towards left, I can call it to y, 2y, 3y, and 4y. Now what I have to do, I have to establish the relationship between these terms and some of the numbers which are given for some positions. So then, based on the fact that this is a arithmetic progression, I can write this number as 32 minus 2y. Then the next number I can write as 48 minus 4y. And the next will be then 64 minus 6y. Okay. So once I have written these numbers, what I have to do, I have to now find out like two equations, or I can make two equations so I can find the values of x and y. That will ultimately lead me to find the number for the given position. So I can first of all establish one equation based on this. So I can then write it 48 equal to 48 minus 4y plus 3x over 2. And similarly, I can form another equation that I can write it like based on this, that I can write like 32 minus 2y equal to 12 plus 2x over 2. So now if I solve these two equations like with any of the methods, then I will get x equal to 20 and y equal to 3. I have just skipped the part of solving the equation because I'm pretty sure you guys know how to use substitution method or the elimination method, and you can do it yourself. And once we have these numbers or these values, so then we can plug these values back into the matrix that we are given and see what do we get. So since I am interested in this row, that is the first row, so I will only focus on that. So in the first row, the first element is unknown. Second, we want to find. Third one, we know expression, that is this. Then the next element is unknown, and then we have 4x. So if I plug this value, I would get 80 for this one. And if I plug this y, then I would get 46. And now to find what value do we have for this one, we can get it by subtracting 46 from 80 and then adding this term. Okay, so this basically, this is our constant difference, right? Or that is 17 if you calculate it. And once I get this value or the constant difference, so then what I can do, I can simply subtract from minus 17, and then I can say that this value is 29, and that is the solution for this problem. So now let's look at problem 22, where we are given that let K be the kite formed by joining two right triangles with legs 1 and square root 3 along a common hypotenuse. 8 copies of K are used to form the polygon shown below. What is the area of triangle ABC? So we are given a kite here, and all the dimensions are given as well. That is here, and this polygon, it is made from 8 kites, right? So let's first identify the kites in this polygon. So if we see here, this is first kite, this is number 1, 2, 3, 4, 5, 6, 7, and 8. So we have these 8 kites here, right? As you can see. Now we have to find the area of this triangle, right? The one that I am highlighting in green. So for that triangle, what we need to know the base. So base, that is AB, and also we need to find the height, right, of this triangle. So once we know the height and base, then we can simply calculate the area of this triangle. So let's first see how we can get the height. First let's go for the base, then we go for the height. So to get the base, we can see that this is an equilateral triangle, right? So then this length that I am turning into red, this length, it is the height of this equilateral triangle. And we know that from this kite that this is square root of 3, this is square root of 3, and then this is equilateral triangle, so this is also square root of 3. So if I write area of a equilateral triangle is equal to 1 over 2 base times height, right? And one side is square root of 3, so then I can calculate the height by also entering the value of base. So now if I simplify, which cross out 2, and then the height that I get is 3 over 2. So this height is actually now representing this dimension. And similarly, since they were the kites that I showed earlier, and they have this length is same for all of them, so this is all 3 over 2. And now if we add these, so we will get 6. So then this dimension from here to here is 6, and for one of the case it is 3 over 2. And now we need to find the height, right? So to find the height, what we can do, we can simply make use of this diagonal, and then we can find this height. Okay, let's call it a H, and this point we have is C. What we know already that from here to here it is 1. This we already calculated, this is 3 over 2. And now we need to know what is the length of this diagonal is, right? This diagonal. So that we can get that from this triangle, the one that I just turned into red. And this is square root of 3, this is square root of 3, this is 1. So if I calculate, then this length AC is equal to simply plus 1 square. And if I calculate, I will get square root of 13. Okay. Now, by using this square root of 13 and this dimension, I can get AH. So AH is equal to now square minus, I have 5/2 square. And that is now equal to 13 minus 25/4. So that is then 27/4. So this is the 27/4 square root, right? Or I can then write it as 3/4. Then this is the height that I get over 2, not 4. And once I get the height and I also have the base, right? So then I can calculate the area of ABC. So then the area for ABC is 1/2 dot 6 dot over 2. So now if I solve it, then I would get 9 square root 3/2. And the answer then for this problem is B. Let's look at problem 23, where we are given that integers a, b, and c satisfy these three equations, and we have to find the value of ab plus bc plus ca. So if you look at the equations, so we have three equations that are ab plus c equal to 100, then bc plus a equal to 87, and ca plus b equal to 60. And in very simple words, we have to answer a question that what is 100 plus 87 plus 60 minus a plus b plus c. So we have to find either the value of a, b, and c, or some sort of combination for them. So let's first add equation 1 and 2 and see if we get some information. So now I will add 1 and 2, and I get AB plus BC plus A plus C equal to 187. And if I factor, then I can write B plus A plus C equal to 187. From here, as we know already that A, B, and C are integers, then the possible values for B plus 1 are plus minus 11 and plus minus 17, right? B that I get, they are minus 12, 10, minus 18, and 16, right? And now let's see what happens if I subtract 2 from 1. Then I would get minus BC and plus C minus A equal to 13. Or I can then write it as, since this is not the same pair, so I would have to write then as a B minus A and A minus C equal to 13. Now the possible values that for B minus 1 that I have, they are plus minus 1 and plus minus 13. And the possible values of B that I would get now, that is a negative 12. So if I see from both of these equations, I'm getting a negative 12 as a common in both. So that means that negative 12 is the answer for B. So now let's see what is the value that is possible for uh, A plus C. So since we know that B is negative 12 and we also know that B plus 1 A plus C is 187. So then if you add minus 10 plus 1, so from here then we can get that A plus C is basically 187 over negative 11. So that is 1 and that is 17, negative 17. So then the value that we want to find for AB plus BC plus CA, that is simply then 100 plus 87 plus 60 minus, we have minus 17 and minus 12, right? Minus 12. So if we solve, then we will get to 276, and that is the answer for this problem. Okay, so now let's look at problem 24, where we are given that a bee is moving in three-dimensional space. A fair six-sided die with faces labeled these is rolled. Suppose the bee occupies the point ABC. If the die shows A plus, then the bee moves to the point A plus 1 BC, and if the die shows A minus, then the bee moves to the point A minus 1 BC. And similarly for the other options. Suppose the bee starts at point 000 and the die is rolled 4 times. What is the probability that the bee traverses 4 distinct edges of some unit cube? So for this problem, if we say like the total possibilities that we have, they are 6 to the power 4, right? And if we solve this, then we will get 1296. So these are total possibilities that we have. But now in order to answer this question, we can solve it by using the case works. So let's make the first case. The first possibility is just assume that at the beginning the face is A plus, right? And then the B, it can go, if it is only moving in the planar, then it can go to B plus, B minus, C plus, C minus. However, it cannot go to A minus. The reason is if it go to A minus, then it will go back to A plus. So we have basically 4 options now. So once it goes to B plus, then the third move can be A minus, and then the fourth move could be B minus. So similarly, the path can be taken for the other options as well. For example, from A plus to B minus, then to A minus, and then to B plus. So if we see the total options then that we get from here, so they are basically 4. So we get then the 4 paths from this case. Now let's look at the second case, or case 2. So in case 2, we are considering now that all 3 axes they are involved. So if we consider all 3 axes, then we can see that again, let's say it starts at A plus, then the next step can be B plus, then A minus. Since all axes are involved, so the last option now it could be C plus or C minus. So if we have these cases and if I consider all of them, then the total paths or the total options that I will get, they will be then 4 multiplied by 1 multiplied by 2, right? or I get then the 8 options. So another possibility that I can have that that would then involve the perpendiculars which will not have a minus in there. So that will actually not having a minus in there. So let's call that case 3. So if we have third case, so I will then go from basically a plus to b plus to c plus to b minus, or I can go to c minus. And so now if I calculate the total options, so they are then 2 and then 2. So I get then 16 options. The total options that I have, they are 16 plus 8 plus 4. And if we add them, so then the total options that I get for the cases where the B can traverse along those 4 edges is equal to 28. However, this 28 is assuming that I start at A plus. However, I could have started any of that. So then I can multiply by 6. So now the total option that I get there, 168. And the probability is simply then the division of the successes divided by the total, that was 1296. And if I solve, then I would get 754. So the answer is then B for this problem. Here we are given that the figure below shows a dotted grid, 8 cells wide and 3 cells tall, consisting of 1 by 1 inch squares. So we are basically given 8 cells here and 3 cells here, and each of that is 1 by 1 inch square. Second, it says Carl places 1 inch toothpicks along some of the sides of the squares to create a closed loop that doesn't intersect itself. The numbers in the cell indicate the number of sides of that square that are to be covered by the toothpicks. And any number of toothpicks are allowed if no number is written. In how many ways can Carl place the toothpicks? So one of the restriction is that for the squares that have 1 written, only one toothpick can be placed for along its edges. So for example, we can have here, but then we cannot place at these locations. Similarly, if we are putting a toothpick here, then we cannot put another toothpick in these positions. Um, so that is one restriction for the edges. And another is, if we note, if we are having along this edge, then we cannot have at the opposite edge. Or if we have along this edge, again, then we cannot have here. Or vice versa. If we have here, then we cannot have it here. So now we will solve this problem by creating different cases. Let's look at the first case. So the first case is very simple, where we can even create the loop without having any of the uh, like without passing through the middle uh, or the second row. So this is our one case, right? And in the same way, we can have another case, that is in this case, right? So we are having now two cases already identified. So now let's see what happens when we go through the center. So as I said earlier, like one of the possibilities would be if we just simply put one here, and then we can have at the edges, right? Now we can create a path like this, and I can have something lesser like this. And now I can have a path like this, right? So if you see, it meets all the requirements. It, in all the cases, it is only touching once along these edges, right? Or in the, or here, and also the other one. So now the question is how many set paths we can have. So simply if you see, now we are having basically 1, 2, 3, 4, 5, and 6 positions left, right? So we basically then create 2 to the power 6 such paths. So let's say now what happens if I start, instead of starting at the extremes, if I start inside, so I can also start like this. And let's say that I go all the way. And now I can have a case like this, right? So there is no conflict. Um, and if we see now, I have 1, 2, 3, 4, 5. Okay, so these would be the ways we can rearrange them. And now if we can, instead of starting at this corner, I could have also started at this corner, right? So that would then give me another 2 to the 5 ways. So now let's see what happens if I also move, instead of starting at the last one, I move that inward. What it means is if I simply create a case, a path like this, okay, so let's see that what is another possibility. So that could be if I just go like this. So in this case, if I see now, yes, it also meets all the requirements, right? So it is touching one here, and yes, okay. So now if I see the options that I don't have, that would be then 2, 3, 4. So I will have then 2 to the 4 ways of rearranging it. So these are the possibilities that I have. So if you will try any other combination, then it will not work. So as I have already told you, based on those restrictions, so the total cases and you get, they are basically 2 plus 2 is 6 plus 5 plus 5 and plus 2 to the 4. So if we add them, then we'll get 146. So that is the answer for this problem.